Hi, Miss Smith. It's Elizabeth Solis, and this is my test replacement project for the rotational dynamics test. And this is a free response question from the AP Barron from the rotational motion unit. So this is a word problem, a free response problem, and it basically reads that a 500 Newton person stands 2.5 meters from a wall against which a horizontal beam is attached. The beam is 6 meters long and weighs 200 newtons. The free end of the beam makes an angle of 45 degrees with a cable to the horizontal and is attached to the wall. So I've drawn the diagram that they gave us, and the first thing that they ask us to do is draw a free body diagram for the beam. So in order to do that, I'm just going to draw out the beam, and over here we're going to have the rotational point, which is O. So that's shown over here. And we're going to be drawing the reaction force at an angle, which is R. And then in the X direction, we're going to have R cosine. So coming down about 2.5 meters, because that's the distance the man is standing, we're going to have 500 newtons because that's how much the man weighs. And then right in the middle, we're going to have 200 newtons because that's how much the beam itself weighs. So going in the X direction, we're going to have the tension cosine 45. And here we're writing 45 because it gave us the angle 45. And then straight up, we're going to have T sine angle 45. And then at the same angle that R is on the other side, we're going to just have tension, which is the cable. So now that we have our free body diagrams drawn, we're going to draw equations, and what we're going to do is take them in the X and Y direction and make them equal to 0. So we're going to do that in blue. So here we're going to make the sum of the forces in the X and Y direction. So we're going to have X, which is R cosine theta minus T cosine 45 equal to 0. And then in the Y direction, we're going to have R sine theta. And we're going to add the tension sine 45. And we're going to subtract 500 newtons as well as the 200 newtons. And we're going to set this equal to 0. So this is one of the equations, and we'll be using these later, but in order to solve for T, we're going to be doing the torques, and in order to do that, we're going to have 0 equals negative 500 newtons times 2.5, because that's the distance the man is standing. We're going to do 200 newtons, and we're going to multiply it by 3 because that's the middle of the beam. And then we're going to add tension sine 45 and multiply it by 6 because that is, tension is at the end of the beam, and the total length of the beam is 6 meters. So that's why we're multiplying by 6. And once you put all of these together, T is going to eventually come out to equal 436.05 newtons. So now that we solved for the tension in the cord, we're going to go on to part C, which is asking us to find the magnitude of the reaction force that the wall exerts on the beam itself. We're going to be using the equations that we made in part B. So we're going to be rearranging this equation. So how we're going to rearrange it is we're going to make R cosine is equal to the tension times cosine times 45 degrees. So when you plug the tension in, it's going to look like 436.05 newtons times the cosine of 485. So this is what you're multiplying together, making our cosine equal 308.33 newtons. So we solved for our cosine, now we have to solve for our sine. So if you do the same thing, now we have to solve for our sine, which once you do the same rearranging and solving for it, you're going to get 391.67 newtons. So now that you have this, you're going to take the ratio to find tangent so that we can find the actual r. So we know that tangent is just sine over cosine. And in this case, we're going to be taking sine, which is 391.67, over the cosine, which is 308.33 newtons. So once you do this, you're going to get 1.27 newtons, and we're going to take the tangent of that, or we're going to take the inverse of it in order to find the degrees. So we're going to do tangent -1, 1.27. And then we're going to get the degree of 51.8 degrees. So this is the degrees that we're going to have to plug into the equation in order to find what r is. So I'm just going to plug it into the cosine because we already know, I showed the work for it, so that's the one that we're going to be using. So I'm going to do r cosine, and we're going to plug in the degrees, which is 51.8 degrees. And we're going to make that equal to 308 because that's the number that we got up here. So we're going to do that. We're going to multiply, and once you divide this by the cosine 51.8, you should get r to equal 498.6 newtons. So this is the total reaction force that the wall exerts on the beam. This is the total amount of tension that's in the cord to hold up the beam and the man, and this is the free body diagram. So this is my test replacement project. Thank you so much for watching, Ms. Smith, and I'll see you in class.